A very good day to everybody. Here we are again with a new webinar for the Stencil Toolbox. So this is a new module that is just been developed by us, and well, you can already see us as UcamX, but first I will have a short explanation how this webinar actually works. Because as you probably already noticed, all attendees are muted, but you still can ask questions. On the right side, there is a questions button. And on the other side of the questions button is our lovely Sylvia. Sylvia, are you there?
Yes, hi Karel, I'm there, of course. Good day to all of you in attendance. While Karel demonstrates our Stencil Toolbox, I will monitor the incoming questions. If possible, I try to answer them directly. If not, so if information is missing or something like that, we will answer that after the demo. And now I give the stage back to Karel.
Thank you very much, Sylvia. So Sylvia will be back at the end of the webinar. And also afterwards, it will be possible to download a copy of the whole webinar, just as it has been done with all the other ones until now. So my name is Karel Langhout and my co-moderator is Sylvia Liemer. So what do we have? We have a short UcamX introduction for the ones who don't know us. We have then a very short introduction to the Stencil Toolbox module, but right away we will go to the live demonstration and afterwards the questions and the answers. Okay, about UcamX. Well, we serve the local PCB industry already for many, many years. We sell laser photo plotters, as probably known by most of you, DIs, the Lydia DI. And we have, of course, what we're talking about today, the PCB manufacturing software, whereas there is, for example, the integrator, the analysis software, like I call it, and UcamX, our CAM software. We also have some web-based products like IamCam or Communicator. We have PCB bundled front-end software, so there's a large chance that you will have some of our software somewhere in your company already. And of course, we are responsible for all the Gerber developments, as Gerber is a format owned by UcamX. So X2 and X3, or the Gerber job format, is all developed by us. Okay, so much already about UcamX, so it was really very short. And now we directly go to the Stencil Toolbox. It already says a whole box of tools for preparing your stencil data. And stencil preparation is a completely new field of expertise where UcamX can help you now to reach your goal. Stencils, well, normally, what is a stencil? Normally it is a metal sheet and it has some holes in it, and those holes are exactly matching to the pads that you have on your PCB. And it is used, normally you put your stencil on the PCB and you put some paste on the stencil, and with the squeegee you can press all the paste into the stencil and onto your PCB exactly on the places where you want to have it. And you can see very nice examples in this little picture here on the side, where you can see, for example, this pad. It has some paste on it. You can also really see that it has kind of a thickness. So this is the thickness of the stencil that's responsible for this. And also interesting is that you can see that the amount of paste, so the size of the paste, is actually smaller than the pad itself. So somebody did something to work on this pad. Also, these small pads over here that you can see, they are not square in the corners. You can see that they are quite kind of rounded. And this is because the paste is, well, it's kind of sticky. It should stick to your pads, but of course it should not stick to your stencil. And here is where, of course, a big problem lies, because after you press all the paste to your PCB and the stencil is still on the PCB, you then have to remove the stencil, and then you get, of course, what you see now, the picture that you see now. But if you remove the stencil and the shape of your pad is not correct, then it can be that you actually also remove the paste. And this is of course not what you want. Then you can start all over again. So that's why it also says it's a stencil I use to apply solder paste on the PCBs in a safe and accurate way. And also exact amounts of solder paste must be calculated and the stencil must be shaped accordingly. So this is also what we talked about. If you need, of course, at some places a little bit more paste, then you can do different things. You can either enlarge your opening a little bit, but you can also take a slightly thicker stencil. Okay, so there's different possibilities there. So all in all, we could say that the preparing stencil is kind of rocket science, and of course with UCAM we have now created a nice tool for a very good lift-off. Now, what tools are we offering? So we have new selection methods because, well, why do we have new selection methods? Because we also introduced new shapes into UCAM. Because for stencils you need dedicated shapes like T-shapes or home plates. We have new scaling methods. We have a critical aperture detection. That's also a nice feature. Of course, we'll talk later about it. We have support for nano coating. We have a bridge builder. We have a super enhanced pet recognition. We have new sorting methods for sorting the openings on your stencil, a corner modifier. So like you can see, there's actually quite a lot we can talk about. So, and that's what we are going to do in the next half hour. So there we are already at the demo. We always like to keep the presentations short, but the demonstration is therefore a little bit longer. This is what you normally have as a stencil. It depends a little bit if you are a manufacturer of stencils, how your data gets in. Normally for people who know UCAM, you will have a complete job here, but also often only the stencil data will be sent to the stencil producer. So then you have only one layer for top and one layer for bottom for your stencils. Now, I talked already a little bit. I will first duplicate the layer so we can actually kind of see what we are doing. We have a comparison. So I have now made a duplicate of the layer. So and the thing is, what we first need to do, we need to get the data in a shape that we actually can work with it. We can see here in our aperture manager, we have a lot of contours and we have a lot of I call it bad data. And why is something bad data? Well, for example, if you look over here, you have something over here where you can see this is not a nice arc. And then you can say, so what? Why should it be a nice arc? Well, there is different reasons for that. I mean, first of all, what I already told before, if the pads are getting small, of course, if you have a smooth area here, a smooth line, the chance that your paste remains there will get smaller. So first of all, you would like to have an arc here because of that. But also, if I want to resize, for example, my arc or have a smaller corner in here, this is not possible if you have all these kinds of lines. So what we actually want to do is we want to change this into some proper pad, let's put it like that. And for that, we have our pad recognition. So if I run this pad recognition on this pad, you already can see that it's now become a really lovely arc. You see all the contours have gone. It's quite nice. Also, if I, of course, put my old data on top, you can really see that it's nicely, that it's been nicely rounded. And also what is very nice, and now I will change now to a different workspace where you can see all the new functionality. So it looks a little bit different now, but you see a lot of new windows have opened. So this is actually also probably new for all the people. what you for now can see, for example, is that we have here the shape coloring, and that's actually quite nice. If I click on this and use a preset, you can now see, for example, that we have different shapes, but also, well, it says D shape. It of course says is because of the D, not because of the different. So we have D-shaped 32 pieces on this PCB, and you can just see that they are over here. We have some squares that are now light blue. We have the rectangles that are green, you know. So we have for all these shapes, even for crosses that are being detected automatically, which is of course useful because you want to handle them probably a little bit different than the rest. So, you know, so you have different types of crosses that are being supported. We have oblongs, oblongs, which is also not a standard UCAM aperture, but now we recognize all those apertures. Also the home plates, but in this data for now, we don't have home plates. I think we will have some afterwards. It's my gut feeling. Anyway, so I'll just go back now to the standard view like this. So now we did the pet recognition, and now we actually can start. And we have quite like a bunch of functions. So for example, you probably want to start with selecting certain data. So, and we have made new functionality also here. For example, I can select D shapes, you know, so if I click on them, you can see over here that the D shapes that we had, they are selected now, or the oblongs. Okay, so these are all the oblongs that they have. So I can directly select something and start working on those specific shapes. Now, we also can do work with width and height on pads, and this is also something new because until now it was we could only work with X and Y, and that's of course not very useful. I can say in this, well, it's of course very useful, but not for the stencils. But here I can of course say I want to select, for example, everything that is smaller in width than 0.22. I press select, and I will have all my pads that are smaller than 0.22. I will have them selected, and I can then start working on them. You know, that's of course the general idea, that when I make some selections, that I can say, okay, I want to resize those pads. I want to do something with them, because 0.22, I maybe cannot, I cannot produce it, you know, so I need to have everything at least at 0.25. So I can then say, okay, I want to go to 0.25, and I have different possibilities of changing the size. I can either say, oh, wait, I want to change the size by a certain percentage, or I can change the size by an absolute value, so 15 microns smaller or something like this, or I can also give it a fixed size, you know. So in this example, I just say, okay, I give it a fixed size, and if I just press apply, zoom in a little bit, and I press apply, oh, then it says you have some circles and squares that have the same width and length. The thing is, of course, if you have something square, you might want to leave it square. So there is actually a warning if you want to do this. So I will just say that, yes, okay, do it now. I will just leave it like it is. And you see now that the pads are now exactly a size of 0.22. So this is already a very easy way to work with this. A nice one is also that you can say, I want to select a certain pitch. So I can say, okay, I want to have a certain pitch of 0.5, for example. I say select, and then you see, okay, these pads here are all have a pitch of 0.5. And also what I can do is combine all those four things together. So I can also say I want to have a certain pitch, but it should be bigger than 1.2. You already see I can do bigger than, I can say in between two values, or I can say at something smaller than or equal. And if I select this, it says, okay, now this, I select now all these pads here from my connector that I have here at the bottom. Now, and of course, with this connector, well, we can of course also say, so I want to change something. I say I think it's too tall, you know, so I will do it 10% smaller. But I can do in the same time, I can say, okay, it should be get a little bit like maybe 50 microns wider or something like this, you know. And I say apply, and then you will see. I hope you will see that it gets smaller in the height and bigger in width. Let's see, apply. And it looks like this. It's amazing. Now, is this useful? Well, maybe this specific example, maybe not so much, but of course there are examples that you are useful. Also, for example, the area where we are again with the solder paste. Like if you want to have maybe a little bit less paste or a bit more paste, you can just easily say, okay, I want to have minus 10% of the area, you know? So, and then I can just say, okay, and I'm done. So that's a very easy way of working with all your pads, an easy way of selecting them, and an easy way of dealing with them. So that's in general already a very good combination. I talked in the beginning a little bit about critical apertures. So, and critical apertures, what are those? There is no window here at the moment for the critical apertures. I have it up here because if you open up all the windows, it gets a little bit crowded, like you see over here. I can maybe make it a little bit smaller like this and put it maybe on top of my aperture manager. It looks also a little bit like the aperture manager, doesn't it? But what do we see over here? Well, first of all, what's interesting is that I can enter a stencil thickness. And if I don't do anything, so you can set a default thickness, like in this case, 150 micron. I have a button here for nano coating, which I just for now will switch off because nano coating will be for sure a little bit more expensive than no nano coating. I mean, it's easier not to have it. Maybe just very quickly, of course, nano coating, it's something like a Teflon foil on your stencil so that the paste will not stick. I mean, that's basically what it is. But let's first say I want to calculate the values for my stencil as they are here. Okay, so what did I do now? I have a certain definition, a rectangle of 0.4 by 0.48, and a foil thickness of 150 micron. This one I'll skip for now, but I can see it has an area, a certain area, and I can see these two values, and these two values are quite important. It's the aspect ratio of this aperture, and it is the area ratio of this aperture. And together they define if a certain aperture is critical or not. And because if it comes below a certain threshold, it will be critical. And this is what you can see here. These values are lower than the threshold and they're nicely color red. However, of course, I have quite some of those and they are everywhere in my table. I can sort this table just by clicking on this column, and I will directly have my apertures here. And I can just say directly, okay, these are the apertures that cause me issue. Okay, this is what is a problem. And now it gets kind of interesting because I can now see here, this is my maximum foil thickness that I could actually use. So if I would use a foil that is 117 microns, all those apertures would not be critical. Okay, so that's something what I can do. But maybe 117 is not okay. Maybe I should say 120. And there's still a few that remain. And I can, of course, what I can do is that I select those apertures. I can go over here, I can select them, and I can directly see in my PCB, in my stencil, where those apertures are located, and if it's feasible to make here maybe a stepped stencil, for example. I don't know if you're familiar with the stepped stencil. There's different ways. What is a stepped stencil? Well, that you have on the same stencil, you have different kind of thicknesses. And there's different ways how you can do this. You can use an etching, for example, on your stencil so that you have at certain areas you etch something away, so you can etch 30 microns down, and then you have a stencil of 120. Or you use depth routing. That's also a possibility. You can weld other pieces in. I mean, there's different possibilities here. So you can actually now look if this is possible to create with something like this, where you can say, okay, I just etch something away to make a less thicker stencil. Okay, so that's what is possible. Like I already said, I have, so maybe I should show this before. Like I already said, I will just click on reset. Of course, I also have the nano coating. Before I go on with the other one, if I dare say calculate, it's boring because there's nothing to show actually. So I skipped it before. But of course, this is easy. This is the easy way out, but it's for sure the more expensive way. So if I would do it like this, everything would be fine. But of course, this one is how you would prefer it. Now, what we can do is we can just say, okay, we go over here and we say for these ones, we will have 120 microns. I need to recalculate. And then you see, okay, I still have these two left. I can from here, I can easily select them. And then I can say, okay, from those that are selected, I want maybe to change the area by. I mean, of course, I can also, you know, I can see them, you know, like over here, and I can say, okay, I want to create enlarge the area a little bit like this. And if I now recalculate, everything is fine. Everything is, so I made my apertures non-critical. There is also something else that you still can see. You have here a divide. Let's call it attribute. And this divide attribute will, if I select this, show you pads that are too big to make like this in the stencil. So I can easily say, okay, these pads that have such a toggle here, I also need to work on them. And what can I do with them? I can say, okay, I want to insert a dam here. So I want to open it up. I want to break it in a lot of pieces. We called it an insert a dam. And for example, here, this is the default. I want to have little pieces of copper from 5 by 5 millimeters. And if I just say insert, it will just nicely insert all those, those dams. In this case, it is 2 in X and 2 in Y. I also have the possibility, because I still have another one. That will be this one for sure. Yeah, there we have it. To use a certain number of dams, so I can say, okay, I want to have 1 in X and 2 in Y, and then I say insert. So I have 1 dam like over here in X and 2 in Y. And you can also see, which is actually quite a nice feature, that if the dam gets longer, that for stability reasons, that the stencil, so the dam gets wider. You know, if you don't want that, you say just, okay, use a fixed dam size like this. Okay, very well. So that is about the stencil analysis. It does quite some work also in the background, but we'll come to that a little bit later. I'll just easily jump. Okay, now what we also have is that you can change the shape. That is what we have down here. So if we go back to our, for example, to our lovely connector that we see over here, where I still can select it, what I can do, for example, is that I say, okay, it is now, in this case, it is an up round. So I say, for example, I want to make it straight, so like this, and I can just, and all things that I have selected on my board are being changed into straight corners. Also, the round, I have a round and I have a chamfer, and the round I can say, okay, I want to have, for example, 0.05. And I have a cutoff of 45%. Well, what is the cutoff? Now you already see that it is actually doing a nice job here. The cutoff is just the maximum that I want to go. If I have an up round, the cutout would be 50%. So then it's the maximum that I have would be half of the pad, so 50%. But normally you would like to have a little bit of a straight line in the middle, because of course the corners are better to work with then. So the 45%, you can also do, for example, I could do 20% and then say something ridiculously big like 1 or 1 over here. Okay, and if I would say shift, right, just select shift, it wouldn't work, because shift. Okay, go back to rounded. Okay, shift. Because the 20% is keeping it from moving it too far to the inside. The same is going for the chamfer. So if I say select and do the chamfer, I will have corners like this. Okay, so this is already also a pretty useful tool. We also have the possibility to change not only the corners, but also the shape itself. So, for example, let me see over here. I can, for example, say I select 2 pads like these 2, and I say then here I say I want to create home plates out of them. But I want to find all the same on the same board, and it just finds all of the same situations on this board automatically. What I can do, because of course what you can have, there is of course something which, there's always something that can go wrong, of course, but this is not going wrong. For example, here I have a situation that is ambiguous. I cannot tell if these 2 pads are belonging to one pair of pads, or these 2 over here, or these 2 over here. This is something I would need to do manual. So we just put it already for you in a small error log, so that you can easily move between the situations and fix those issues. So we'll look at this a little bit later. For now, we will just see, okay, we have here those pads, and what I can just do is I say, okay, I shift, and what does shift mean? Well, I shift between shapes. Okay, so now I have just one with a ratio from roof to wall of 0.5, base to base, normal. But of course, if I want to have it the other way around, I can use the tip to tip like this, or I can say I want to have inverse, so inverse home plates like this, or a different ratio. So there's quite some things you can set here. Well, let's make it at least not an inverse one. So something like this. Okay, that would be pretty, let's say, pretty standard. So if I'm satisfied with this, I can then go and go with these ones that were an issue before. Okay, so, and I can still say I say manually, because of course it was not possible to do it automatically. I say these ones, I want to make a pair of it, and so this is also a way of dealing with that. Oops, this I didn't want to click. I want to click here, and I have also can do this one and say make a pair of them, and now we're done. Okay, so that's actually a very nice way of well, I think over here, everywhere now we have we have the home plates. I think if we look over here, you can see we made 324 of them. So if I make them now blue and switch on my colors, you can nicely see where they are. Okay. So, okay. So let me see. Now the stencil is already quite, let's say, far. The only thing maybe that you want to do is now say, okay, I have still certain, but it's already done. Like before this, were of course all rectangles, but I already rounded them before because I had a rounding that I did on when I was demonstrating this here, and I did it actually secretly on all the data already. So I'm sparing this now. Anyway, it doesn't matter so much. It's actually what I wanted to do right now, but I already did it. So then we are already almost done. There is one thing left, or actually two. We have, for example, the plot that I want to give to my production. And well, what does it do? Well, it will just create a new layer with a called control plot, and it will divide your PCB in 9 different areas. And for all the different areas, you will get the smallest pad listed over here. So the smallest size, okay? Like over there and over there. And what you get is a size so that people can measure in your production. They can measure the size between 2 pads. And maybe sometimes the automatic mechanism is not too good there. You would like to use a different one in a certain case. Well, that's easy. You can just say, okay, I want to go over here and I want to do a second pad, and it should be the one here in the corner and not the one in the middle, and I want to do a third pad. So it is a very easy way of just quickly setting up a small drawing. Also, if you say these are too many, you can of course also say I want to have a few less. So I can actually say I want to have only 2 points, for example, bloop, and then you get only 2 points. And so to make it maybe a little bit more obvious what is meant, or that you only have, this is really the smallest points that are on the PCB, you know, so on the stencil, sorry. So this is for your production. And now you still need to have some output. So, and the output, well, it depends, of course, a little bit. If you do use also etching for etching away the openings also, then what you of course can do, you can just create a film and you can do your etching directly on the stencil. If you use something like laser cutting or something like this, I mean, there's also quite a lot using that. You can sort the openings that we have over here. So, and there's different ways you can do this. So you can sort it by stripe, or so, and what it will do, it will go through the PCB like this. So, or you do it by a spiral, so a rectangular spiral like this, or you can do it by a circular spiral like this, or by pad rotation. Now, I will just do sorting by stripe. I say sort, and it will create a sorted layer. And the interesting bit is what you now will see is that you actually get only one flash or only one region. And this region, it's good. The whole table is now exactly sorted like in this layer over here. So you can have a visual feedback of how the sorting has been done. Okay, so all the openings are being sorted, and well, your output will be like this. So in this, of course, you can then output, well, if your laser is a CNC, you can use auto drill, for example, to create the output, or you can output it on a film. So this is, yes, this wraps up the whole, well, it's of course done very shortly now, but it wraps up the whole working process that you will do on the stencil. So the only thing that remains is to talk about a few benefits. What we talked about already is streamlined workflow, saving you a lot of time and money. Very good recognition of the pad shapes, which is very important, what we talked about. Also, stencil specific shapes can be used. The incoming data quality does not matter, because we if it's too bad, we just simply recreate the pads. We have an instant overview of all the critical apertures. We can reshape the pads for an optimal paste cohesion. We have nano coating support and also a technical drawing. So there's not much left, I hope. So there's no wishes left, let's put it like that. But maybe Sylvia has some questions by now.
Yeah, most of the questions are already answered. Others need additional information, or I have to do a little bit of research, and they will be answered after the webinar. There was one question I think that could be interesting for the whole audience, and that was if it is possible to only get some of the tools, or if it is one tool which contains all the functionality. So Stencil Toolbox is only available as one option, either as on top of an existing UCAM seat or as a dedicated stencil seat, but not single parts out of them. I hope that answers the question, and because our time is getting to an end, so I think we should wrap up and the rest will be answered later.
Okay, very good. So, well, then I have nothing else to say that I hope you enjoyed this webinar. Thank you, everybody, for listening. If you are interested, well, you can always request a trial version at sales@ucamco.com. As Sylvia already said, the unanswered questions, and if you ask some, well, we will answer them afterwards. So we are looking forward to your feedback. It is for us also, it is a new module. Maybe you say, well, I would like to have maybe some extra functionality. We are always willing to look into this. I mean, this is also what we are. I mean, this is how we became what we are now, because we always listen to our customers. And so if there's, yeah, well, we, of course, if in the future, of course, we will inform you about the new webinars. And well, thank you very much again for attending. Have a very nice day, everybody.
Bye-bye.